close. Okay, so this table doesn't, because it's more than 2 by 2 table, so it doesn't give us what we are looking for exactly, but it gives us an indication about this relationship. So if we look at all use or use of social media all the time, we notice that Balqa University, they depend mainly on social media as a source of COVID information 42 times, 42% of the times. Hashimat University, 23.8%. Jordan University, 33%. Yarmouk is 36%. If we look at Never, Balqa 15%, Hashimite 22%, Jordan University 15%. Just similarly, we have the same here. So it doesn't tell us which one is greater than the other, which percentage is greater than the other, because we're not comparing 42%, for example, to 32%. We're not comparing 42.2 to 23.8. This comparison that we are having, the 0.004, compares these two variables, university and social, and compare specific numbers within the cell. So this chi-square, Pearson chi-square, this is the value of the Pearson chi-square. This is the actual value of the chi-square, and this is the p-value. This chi-square test tells us that there is a relationship between university and social media utilization as a main source of COVID. It doesn't, however, tell us which one is greater statistically, but we can say there is a difference in the distribution of participants by social media utilization and university. It seems there is one university that's using more or less than using more or less social media as a main source of information. We see that the lowest here is 23%, and then we can talk about these percentages. Hashimati University had the lowest utilization with 23.8. The highest was for Al-Balqa University with 42.2. However, the differences are not between this number and this number. The differences is for all numbers. It doesn't give us an indication of which one is greater than the other. So this is the chi-square test. Again, we are comparing, if we go back to the table, we are comparing numbers, absolute numbers. We are comparing numbers within this table. So when we see a table that has actual numbers, that we can calculate percentages and we can calculate proportions, then we are using chi-square. Now the other one that we have to talk about is the t-test. Is the t-test. So if we go back to this using variables where the anxiety, worry, the panic, loneliness, and nervousness. Okay, wait. If you see anxiety here, if we click hearing information about COVID-19 has increased, then we gave you a code of 3, and we gave you a code of 1 if it decreased. So each participant was coded either 3, 2, or 1 for anxiety. The variable is anxiety recoded. This is the main variable. Somebody asked me yesterday about how to deal with drive. This is how they came. Increase, did not change, and decrease. Okay. Now I just recoded them into increased. I gave it a code of 3. Did not change, gave it a code of 2. And decreased, I gave it the code of 1. So you have a worst case scenario of the anxiety level has increased. You have a regular scenario if it did not change. We coded at 2. And if it decreased, which was odd, we gave you a code of 1. Okay, so if we look at these variables, we have anxiety, we have worry, we have depression, we have panic, and we have loneliness, nervousness. What else? These are negative emotions. We have 5 or 6 negative emotions. Positive emotions starts with happiness. We have 3 or 4. Okay, so imagine if we added for each participant, we created a new score that's called positive, negative emotions. And we added these scores. So if you scored 3, we added this first score, which is 3 for anxiety, 3 for worry, depression, we added another 3, panic, 2, loneliness, 2, nervousness, 2. So this participant will have 2, 4, 6, 3 is 9, 3 is 12, and 3 is 15. This specific participant will have a score of 15. So how are we going to do this? We have to create a new variable. We go to transform, compute variable. Transform and compute variable. Okay. And we're going to call it, this is the target variable, the new variable that you are computing. The new variable will be called negative, no spaces, emotional state. Called new. You can give it whatever name that you want, just a name that you can, that does not exist in the dataset. Negative emotions, negative emotional state, negative emotional state new, negative emotional state scale. Okay. Now, this new variable will be adding 6 variables. So the first variable will be anxiety. So we double click on anxiety, it's going to jump to this box. Okay. So if we double click on anxiety recoded, it's going to jump into this box, and then we add plus, and we go down to worry recode. Okay. Then go down, depression. Oh, sorry. We add plus, depression recoded. Go down to panic recoded. We did not add the plus. Loneliness plus loneliness. And the last one was We add a plus, nervousness equal. So the aim here is to create a new variable that has the summation of all the values for these 6 variables. Now each of these 6 variables is coded as 1, 2, or 3. It has a value of 3 if you have the worst case scenario, which is you have increased emotions, increased negative emotions. You had 2 if everything stayed the same, nothing has changed, and you had 1 if things were the opposite of what we expected. Okay, so instead of showing 6 or 7 tables, we will show one main big table. Okay, then we hit OK. So nothing has changed. It just gave us the formula with what we have done. We have computed a new variable that we called negative emotional state new, and it included anxiety, worry, depression, panic, loneliness, and nervousness. Okay, we just added the actual values of these 6 or 5 variables. Now, these variables are numeric variables. It'll just take the number and add it. It's gonna simple addition thing. If they were string, if they were text, it's not gonna work because it cannot add string values, text values. It just adds numeric values. Now, if we go back to the data set, the variable view, all these values are here, negative emotions, and I'm just gonna add a label here and say negative emo created by we look at this value. These values are for each individual. So the first subject scored 15. We said we have 6 variables that we added. Each variable is coded maximum of 3. So 6 by 3 is 18. So the maximum score will be 18. The minimum score will be 6. Okay, because if you score 1 for each, 1 by 6 is going to be 6. So for this new variable, we need to show descriptive statistics. We have to go, these are not actual numbers. We can actually create a mean for these. So this is when we do descriptive statistics. The new variable will be all the way at the bottom. Okay. Again, so we now switched from a table that has actual counts, actual numbers. So the chi-square tables, we were counting number of cases or number of participants. Here, we're not counting number of participants. We are giving a score for a series of values. So we cannot use chi-square. We have to go back and do, instead of frequencies, descriptive. We have the value variable in here. Click options, click all these, continue, and OK. So this new variable, which is called negative emotions created for students, was created for 1404, which is the whole sample size. It has a minimum score of 6. So people really scored 6. They were happy for all these values. a maximum score of 18. It has a mean of 14 and standard error of 0.057. It has a standard deviation of 2 and a variance of 4. These are all what's called by descriptive statistics for that specific variable. Now, because this is a variable that has a range between 6 and 18, we actually can do a frequency distribution. Reset, we go all the way down. This is the minimum. 10 students answered decreased for all negative emotions. Okay, now the majority of students actually were 12, 13, and 14, and 15. So, is this negative emotional scale or state, is it higher among males or among females? So, now we have to look into what's called by compare means. Compare means we go to one sample, sorry, we go to independent t-test, and we have the test variable is the variable that we need to create the mean to, and the grouping, you need to compare the mean for two main values, which is gender. So you need to compare. So the t-test is used to compare two means and two means only. It doesn't compare more than two means. So we need to compare the negative emotions or negative emotional state by gender. Now, how is gender coded here? If we right click, it's coded as 1 and 2. 1 for females, 2 for males. So it's coded as 1 and 2. You cannot still click OK because you have to define groups. So you have group 1, which is number 1, group 2, which is number 2. Do it again. So we analyze, compare means, independent t-test. We have the new variable, the variable that we need to create the to compare the means for, and then there's 1 and 2. If you look at next to the variable, this variable is being dealt with as we call it nominal variable. This should be a scale variable. So this is the summary table that we have, and emotional state among females was 14. Among males, the mean was 13.5. So the mean emotional state was 14.4443. Among males was 13.5343. So it seems that from knowing the variable, the higher score means you have more negative emotions. Female had negative emotions for this sample. When we report a mean, there should be a standard deviation next to it. So it has a mean of 14.4 and standard deviation of 2.09. Males 13.5 with a standard deviation of 2.1. Now, is this significant? Is this a real difference for this sample? But is there a difference between males and females in terms of negative emotional state at the population level? We look at the significant two-tailed, which is this value, and this value is highly significant. So the p-value is highly significant. So the difference that I'm observing between emotional state for males and emotional state for females, even though it's minimal, but it's still statistically significant. So female student showed higher negative emotional state compared to male students, and this was a statistically significant difference. So the mean negative emotional state for females was 14.4, standard deviation of 2.09. Among males, it was 13.5, standard deviation of 2.1. This difference was statistically significant with a p-value of 0. This is a really low p-value. If we click on it, this is the actual p-value. 6.2 exponential minus 15. Okay, so this is a really low p-value. Okay, so within the sample there is a difference. Within the population there is a statistically significant difference between the mean emotional state for females and the mean emotional state for males. Okay, again, compare means, independent t-test. Now let's do this for clinical years versus non-clinical years. So if we go all the way down and create the same comparison for clinical years. So if we click on the variable, we see that this variable is coded as 1 basic medical education and 2 as clinical education. 1 representing first and second and third year of medical school, 2 representing the fourth, fifth, and sixth. So we are comparing group 1 to group 2. Nothing has changed. And we just hit OK. So is there a difference between emotional state between basic medical education and clinical education? There is. The p-value is highly significant, and the mean is 14 compared to 13. 14.2 with a standard deviation of 2.17 compared to 13.79 with a standard deviation of 2.13. Now this is the relationship between the negative emotional state, which is a scale variable. If we go back to the data set, if we go to the, variable view, this is the variable that we've created. It was the last one. And here it should say that this is a scale variable. Again, a scale variable is a variable that we can create a scale when the values between any two numbers is infinite, which is the case of this variable. Now, is the emotional state different by university? If we go back to the university, universities have been created, or the variable university has more than 6, it has 6 actual values. So if we go back and do a t-test, it's not going to work because a t-test will compare only two values. That's why we need to hit what's called by one-way ANOVA. So comparing the means could be done with independent t-test or one-way ANOVA. Now we have what's called by paired sample t-test. Paired sample t-test is when you are comparing a value to another value for the same individual. So we can take, for example, the blood pressure reading at visit 1 to blood pressure reading at visit 2 and see if there has been an improvement. So we calculate the mean blood pressure reading at visit 1, and then in 2 weeks after giving the patient the medication. This is called paired t-test. So it's paired because the same value is paired to another value in a different time. So it's the same individual, the same patient, and compares one single value at two different points in time. That's why they call it paired. So we have independent t-test and we have one-way ANOVA. Okay. So with one-way ANOVA, what we want to do is to compare the emotional state to what's called by university. Okay. And this is what we are looking for, but this doesn't give us any mean. This table doesn't give us any mean, but this is the actual comparison mean. It takes what's called by sum of squares and calculates a critical value compared to a calculated value, and then this is the p-value that we're looking for, but this has nothing to do with what we are looking for because it doesn't give us actual means. One-way ANOVA, we want descriptive data, so you want descriptive for your comparison. So with a descriptive, it's going to give you what you want, which is the mean. So Balqa University, they have a mean of 14. Hashimat University, they have a mean of 13. Jordan University, you have a mean of 14. Just you have 14. Mu'ta 14. And Yarmouk University is 14. So this data was a little bit interesting because the mean was actually very high. So most of the students have scored values that are adjacent to or within within the maximum level. So almost all students have scored high negative emotional state. High negative emotional state. So if we look at the mean by university, it's going to be between 13.5 and 14.3. So almost all universities, all students within these universities have scored high levels of negative emotional state. So these are the means. This is the standard deviation. A mean goes with a standard deviation all the time, okay? Now, this is what's called by the 95% confidence interval. So a 95% confidence interval, how confident are you in your mean? So this mean, I'm 95% confident that this mean will run between 13.6 and 14.1 for Al-Balqa University. So this value 14.05 will run between 13.6 and 14.6 here. Al-Balqa University, the mean is 14.05 or 0.5. This is the standard deviation. And 95% confident that the mean will be between 13.63 and 14.46. What does this mean? This means that if we repeated the same exact thing, the same exact study, 100 times. So if we selected 100 samples, if we conducted the study 100 times on the same sample size, the lowest mean, I am confident that 95 times of these samples will produce a mean between 13.6 and 14.4. So 95% confidence interval gives you an indication of how confident are you in your sample. Now, when I'm doing a sample, I'm expecting values that may be compared or maybe similar to the actual values. So the mean of the sample, I'm expecting it to be representative to the mean of the population. Okay, so how confident I am? My confidence level depends on the sample size on mainly. So if I do the same exact measure on 100 samples, 95 of these samples will have a mean between 13.6, the lowest limit, and 14.4. Now this 5%, which represents the alpha level, is what's called by chance. This is where I'm just going to let you play with chance. I'm going to let you do obtain some results due to chance. Now these chances are due to the fact that I'm not measuring the whole sample. I'm just the whole population. I'm just picking up a sample. I'm selecting a sample. When you select a sample from a population, then you expect some deviation, some increased values, decreased values. You never know what's going to happen. So within this table, the ANOVA told me that there is no statistically significant differences between university and the mean negative emotional state. Negative emotional state. Okay. We can do the same thing, compare means, one way ANOVA, and do no, let's do with social media. Social social media, it's called social media. Okay. Okay, so let's go back and recode social media so it's numeric. Remember we said that recode into new variable, we reset social media. Sorry, let's go back and auto recode. So if we do auto recode for social media, and it's called social coded. If I hit add new name, these marks are gonna change. Hit OK. Now I have a new variable. If I do it frequency distribution, maybe the last variable. Okay. So what I did is I changed the social media from all most of the time into one and labeled it all most of the time, never into two and labeled it never, and rarely into three and labeled it rarely. Can you all do that? Did you all do that? Can you do the auto recoding for the variable that's called social media? Okay. So compare means one way ANOVA, and the new variable that we've created is going to be all the way at the bottom. So there is a statistically significant difference in these means when compared in the mean of negative emotional state when compared to social media utilization. Okay, so those who have utilized social media as a main source of information will have highest score. This is interesting. So if you are using Facebook, Twitter, Instagram, whatever it is, for as a main source of information for COVID-19, then your emotional stress due to COVID is going to be high. So you have scored 14 in terms of mean of emotional state. If you are using it rarely, you have, or sometimes your score is 13.9. If you never used it, then your score is lower. Okay, so your mean level of emotional stress or mean emotional stress state will increase with more utilization of social media. Now, this was an overstatement. Well, what this table actually tells us is that the mean, these means, these three means, they depend on social media utilization. So the mean emotional state depends on social media utilization. There could be statistically significant differences between these means, but at this stage, this table only tells us that there is a difference between these three means. Okay, and this difference is highly statistically significant. Okay, so the mean emotional state for those who depend highly or all the times, most of the times on social media is 14.4, standard deviation of 2. If you rarely depend on it, your mean is 13.9 with a standard deviation of 2. If you never, then your mean is 13.6. So it looks like those who never use social media as a main source of information will have the lowest mean. Okay. Now, what does this mean? This doesn't compare the 14 to the 13 or the 13.6 to the 13.9. Doesn't compare never to all most of the time, or doesn't compare never to rarely and sometimes. How can we do this? So if we want to do a comparison between two specific means, we can do this. But before going into that, the first thing with ANOVA is to see all these means, are they different or not? Is there a statistical significant relationship between the two variables, which is social media utilization and negative emotions or negative emotional scale? The relationship between these two variables was statistically significant. Now, once we discover that this is a statistically significant relationship, we can go back and do what's called by post hoc analysis, which is comparing the categories or the means themselves for each category. Okay, so this is post hoc. We want Tucky's test. Okay, again. Now, once we are done with this and we have a p-value indicating significance, then we need to say which are these values that are significant than the others. So this is going to give us a new table. This is the same exact table with the post hoc analysis. Now the post hoc will give you, it will compare the mean for all most of the time, which is 14.4, which is here. So the mean for all or most of the time will be compared to never. So it will give you the difference between these two means, which is the mean difference, give you a standard deviation and tells you if it's significant or not. So this first one took the first mean, which is all or most of the time, and compared it to the mean in the never category and the mean in the rare sometimes category. The difference between these two means, which was 0.7. So all it did is subtracted the never, which is 13.681 minus, or 14.4023 minus 13.681. This is the difference between them. This is the value of the difference. So it's subtracted or give you the difference between these two means. This is the difference. The mean, the difference between all most of the time with rarely sometimes, this is the difference, and this was statistically significant. So there was a statistical significant difference between the mean for those utilizing social media all the time or most of the time with those utilizing social media with those never utilizing social media as a source of information for COVID. And there was a difference for those utilizing all the time, most of the time, with those utilizing rarely or sometimes. These are statistically significant differences. This is the first comparison. Now, never, if you compared never to rarely, there is no significant difference. So the mean emotional state, negative emotional state, for those who never utilize social media as a source of information for COVID, when compared to the mean of those who rarely or sometimes use social media as a source of information for COVID, the difference was 0.26, but this difference was not statistically significant. So those who used it all the time seem to have higher negative emotional state compared to those who never used it and used it sometimes or rarely used it. Okay, so this is again, this is the ANOVA table. It gives us an indication. We look at it at these two tables at first. We look at the means, standard deviations, okay, and we look at the p-value. If the p-value is significant, we move to what's called by post hoc analysis. But if this was not statistically significant, we just say there's no significant relationship between social media utilization and negative emotions. Social media utilization and negative emotions. Now, now you guys have the data set. You have a clue of what's going on, how to compare numbers to numbers using chi-square, and how to compare means by subcategories. And I highly suggest that you go on and start playing with this data. The more problems you will have, the more difficulties you'll have. You can come and ask questions tomorrow. It makes more sense to play with this data. This is a data set that you have created. This is something that you have answered and provided the answers for. And it gives you more applied statistics. It gives you more application of statistics from whatever you've taken during the second year in terms of chi-square and ANOVA tests. And it's a good opportunity for you to get more engaged with data analysis. This is something that most researchers do not do. They just give the data to somebody who will do the analysis for them. They have no clue what's going on, how things go in the back burner. But this is something that could be of interest to you if you want to move into doing research. Now, this data has been published with 3 medical students. So part of this data is already published with Frontiers in Public Health, knowledge, I think it was knowledge, attitudes, and precautionary measures among medical students in Jordan. Okay, this will conclude the lecture today, but I want to give you more chance to go and explore with the data. And tomorrow, if you have any question, just come back with questions, please. Do you guys have any questions before we go on?
دكتور عندي سؤال إذا سمحت بس.
أعمى.
شو الفرق بين الاندبندنت تي تيست والون واي انوفا؟
هلا independent t-test and the ANOVA are comparing means in a different way, but independent t-test will compare the actual mean to the actual mean for 2 categories. So if you have a variable with 2 categories, like gender, males, females, then you go for independent t-test. If you have a variable with more than 2 categories, 3 categories, you go with ANOVA. Now, the way the comparison happens is different. ANOVA, it's called analysis of variance, So it kind of gives you the p-values and the critical values using the variance, the variability around this mean. So the way they perform is different, because in the t-test, independent t-test, you are comparing 2 means. When you compare more than 2 means, 3 means or more, then the way they perform the analysis is different. For you guys, if you want to compare 1 mean to 1 mean, you use independent t-test. If you want to compare more than 2 means, 3 means, you go to what's called by ANOVA, analysis of variance. Okay?
تمام. بس كمان شغله دكتور، هلا لما عملت ريكودد انت في مجال لو طريقه ثانيه نعمل ريكودد من فاريبل فيو، انه نروح على الفاليو ونغير الفاليو احنا نفسها، يعني قبل شوي زي لما حطينا مثلا.
hold on. خليك معي عمار. هلا انت عمار بدك تروح على الفاليو هون تغيرها.
بالضبط.
طيب هلا خلينا ناخذ احنا الجندر مثلا. احنا حطينا الفاليو تبعته ميل وفيميل. لو حطينا 3 كانت فيميل مثلا. Okay. This is what's going to happen here is that the actual data has 1 and 2. It will come to this number 1 and gives it a value. It gives it something that you will see. The actual number that will be used in the analysis is 1 here and 2 here. Halo, you add 3, it's not going to show up here because you actually have no number 3. مش احنا هون حطينا رقم 3. Number 3 is not part of the data. It's not going to show. Now what you can do, احنا ايش عملنا؟ ايش غيرنا؟ ايش الفاريبل اللي غيرناه؟ اللي هو social media utilization. السوشيال ميديا هون هو ما له values لأنه social media was actually a text variable. Okay, now you need to go back and convert it into numeric variable, so it will change. It will be able, you will be able to analyze it, but there's no way to change it from here unless you want to do. You can do this, but it's going to be manual process. If you sort, now we wanted to change this into number 3. So I hit 3, copy number 3, and do this. I will just change it into number 3. Say it ends here, paste. This is the only way you can change it. But this is a manual process. It doesn't make any sense. You can change it from here by recoding into same variable. Okay, so you want to say I want social media. When it says all most, then you hit add. So this is one way to change it. Okay, variable you have